Erwin DM, working with Snowflake. For more details and most recent content on this topic, please refer to the current Erwin DM bookshelf. Snowflake continues to grow as the DBMS solution of choice for many organizations. Erwin DM 2020 R2 now has full native support for Snowflake, which includes reverse engineering, complete compare, and forward engineering capabilities. All standard Snowflake data types and parameters are supported. Since Snowflake is natively supported, along with our other DBMS systems, existing data structures can be reverse engineered and then converted to Snowflake and forward engineered into Snowflake, thereby facilitating your migration to Snowflake. As you can see, all native Snowflake data types are supported. Defining Snowflake objects. In the Model Explorer, right-click the desired object type and click New. Right-click the newly created instance and click Properties. Set the values of all the required properties and close. The desired object is created and the required properties are set. Snowflake is a software-as-a-service analytic data warehouse that is faster, easier to use, and far more flexible than traditional data warehouse offerings. Snowflake's data warehouse is not built on an existing database or big data software platform such as Hadoop. The Snowflake data warehouse uses a new SQL database engine with a unique architecture designed for the cloud. To the user, Snowflake has many similarities to the other enterprise data warehouses, but also has additional functionality and unique capabilities. Defining Snowflake database roles. Access control privileges determine who can access and perform operations on specific objects in Snowflake. Role-based access control, RBAC, is one method where Snowflake access privileges are assigned to roles, which are in turn assigned to users. Here you can see how the roles are supported in Erwin DM. Defining Snowflake file format. Snowflake supports structured or semi-structured file formats shown here in the Erwin DM drop-down list. File format options specify the type of data contained in a file, as well as other related characteristics about the format of the data. The file format options you can specify are different depending on the type of data you are unloading to. Erwin DM supports Snowflake's full set of file format option defaults. Defining Snowflake user-defined functions. UDFs let you extend the system to perform operations that are not available through the built-in system-defined functions provided by Snowflake. Erwin DM currently supports both types of UDFs, SQL and JavaScript. A SQL UDF evaluates an arbitrary SQL expression and returns either scalar or tabular results. A JavaScript UDF lets you use the JavaScript programming language to manipulate data and return either scalar or tabular results. And here you can see an example of Erwin DM support for Snowflake's UDFs. Defining Snowflake Materialized views. A materialized view is a pre-computed dataset derived from a query specification, the select in the view definition, and stored for later use. Because the data is pre-computed, querying a materialized view is faster than executing the original query. This performance difference can be significant when a query is run frequently or is sufficiently complex. Erwin DM allows configuration of Snowflake's materialized views. Defining Snowflake pipes or Snowpipes. Snowpipes enable loading data from files as soon as they're available in a stage. This means you can load data from files in micro-batches, making it available to users within minutes. Snowpipes load data according to the copy statement defined in a referenced pipe. Here you can see the copy statement as part of the Snowpipe object in Erwin DM. Defining Snowflake schema. All data in Snowflake is maintained in a database. Each database consists of one or more schemas, which are logical groupings of database objects, such as tables and views. Snowflake does not place any hard limits on the number of databases, schemas within a database, or objects within a schema, You can create an Erwin DM displays these in the Schema branch along with the relevant configurable properties. Forward engineering Snowflake schemas. The Snowflake physical model can generate some or all of the DDL used to update or forward engineer your Snowflake environment. Defining Snowflake security integrations. A security integration enables clients that support OAuth to redirect users to an authorization page and generate access tokens and optionally refresh tokens for access to Snowflake. The Erwin DM Securities Integration branch shown supports browsing and configuring Snowflake security integrations. Defining Snowflake stored procedures. Stored procedures are loosely similar to functions. As with functions, a stored procedure is created once and can be executed many times. Although you can run select statements inside a stored procedure, the results must be used within the stored procedure or be narrowed to a single value to be returned. Erwin DM allows configuration of both JavaScript and SQL within Snowflake stored procedures. Defining Snowflake sequences. Sequences are used to generate unique numbers across sessions and statements, including concurrent statements. They can be used to generate values for a primary key or any column that requires a unique value. Again, the Erwin DM Model Explorer's Sequences branch supports browsing and updating Snowflake sequences. Defining Snowflake streams. When created, a table stream logically takes an initial snapshot of every row in the source table by initializing a point-in-time offset as the current transactional version of the table. The change tracking system utilized by the stream then records information about the DML changes, insert, update, delete, committed after this snapshot was taken. Change records provide the state of a row before and after the change. Change information mirrors the column structure of the tracked source table and includes additional metadata columns that describe each change event. Erwin DM makes it easy to configure Snowflake streams. Defining Snowflake tables. All data in Snowflake is maintained in a database. Each database consists of one or more schemas, which are logical groupings of database objects, such as tables and views. It should not be surprising Erwin DM supports Snowflake tables. Defining Snowflake tables external. The checkbox is external defines an external table. In a typical table, the data is stored in the database. However, in an external table, the data is stored in files in an external stage. External tables store file-level metadata about the data files, such as file name, a version identifier, and related properties. This enables querying data stored in files in an external storage stage as if it were inside a database. External tables are read-only, therefore no DML operations can be performed on them. However, external tables can be used for query and join operations. Views can be created against external tables, and querying data stored external to the database is likely to be slower than querying native database tables. However, materialized views based on external tables can improve query performance. Defining Snowflake tasks. General. Currently, a task can execute a single SQL statement, including a call to a stored procedure. Tasks can be combined with table streams for continuous ELT workflows to process recently changed table rows. Tasks can also be used independently to generate periodic reports by inserting or merging rows into a report table or perform other periodic work. And again, Erwin DM Model Explorer can display and configure Snowflake tasks. Defining Snowflake tasks, session parameters. Another important feature of Snowflake tasks are the use of session parameters. You can set session parameters for the session in which a task runs. To do so, modify an existing task and set the desired parameter values, easily accomplished within Erwin DM. Defining Snowflake users. Security and account administrators, i.e. users with security admin role or higher, can create and manage Snowflake users. Erwin DM can help manage Snowflake users, and the default role in the property editor is shown here. Defining Snowflake views. Views serve a variety of purposes, including combining, segregating, and protecting data. erwin supports both types of Snowflake views: non-materialized views, simply referred to as views, and materialized views. Snowflake warehouses are required for queries as well as all DML operations, including loading data into tables. A warehouse is defined by its size as well as other properties that can be set to help control and automate warehouse activity. Warehouses can be started and stopped at any time. They can also be resized at any time, even while running, to accommodate the need for more or less compute resources based on the type of operations being performed by the warehouse. Here are the parameters supported by Snowflake and erwin. Finally, auto document. Reverse engineer. You can connect to a Snowflake database to reverse engineer your environment using generic ODBC driver or a JDBC driver. In this example, the Erwin reverse engineer and erwin Snowflake connection dialogs are shown. This allows some or all of the Snowflake objects to be automatically imported into erwin, a process that can now be scheduled for off hours. So that's it. A quick look at how erwin works with Snowflake. Thanks for watching.